Hello everyone. Today we are going to learn about acids. So in your Edmodo, go to the post that says acids. We have the link for the reading. We have the practice questions, and we have my email that you can send your answers to. So let's take a look at acids. So an acid can be defined in many ways, but in chemistry, we define it as a molecular compound that contains one or more hydrogen atoms, and it produces hydrogen ions when you dissolve it in water. Okay, so since acids produce H-cations, so hydrogen cations, when they dissolve in water, the H of an acid is always going to be written first in the formula of an inorganic acid. There are organic acids, but we are not going to be talking about those right now. Okay, so the remainder of the acid after the H is going to be the anion after the acid dissolves. Okay, so a binary acid is going to be an acid that consists of a hydrogen and one other element. That's probably going to be the majority of what we'll look at. The most common binary acids are going to contain a halogen. So those ones with 7 valence electrons. An oxoacid is going to be an acid that contains hydrogen, oxygen, and a third element. Third element usually being a non-metal. So how do we name acids? All acids have hydrogen. So the name of an acid is going to be mostly based on the anion that pairs up with it. So the anions, they can be monatomic, they can be polyatomic. So all monatomic ions, ones that are made up of one atom, those are going to end in "ide." The majority of polyatomic ions are going to end in either "ate" or "ite." One exception is going to be the cyanide ion, and we'll see how that works in a little bit. But the suffix of the anion determines how the acid is named and how it is showed. So, 3 different suffixes for the anions. When we have the "ide," the acid is going to begin with hydro for the hydrogen, and then we have the root of the anion, and then we have the suffix "ic." Okay? So, for example, if you have hydrogen and chlorine, it's the chloride ion, so it has the "ide" suffix. So we have hydro, the prefix, and then we have chlor, the root, and then we have the "ic" suffix, and then we have the word acid. All right. If it's HCN, it is hydrocyanic acid. All right, because CN minus is going to be cyanide. When the anion ends in "ate," the name of the acid is going to be the root of the anion, so no hydro, root of the anion, followed by the suffix "ic." All right, so sulfate, for example, it has the "ate" suffix. So we do the root of the anion, sulfur, and we get sulfuric acid. All right, it's not sulfic, it's sulfuric. When the anion ends in "ite," it is going to be the name of the acid, is going to be the root of the anion, followed by the suffix "us." Okay, no prefix, no hydro. So HNO2 is nitrous acid. Okay, it has the nitrite ion, it has the "ite" suffix. So it has the root, the niter, and it makes nitrous acid. All right. How do we balance them out? Well, what we do is we can use the crisscross method as shown here. So if you have hydrogen, which is +1, and sulfate, I think that's sulfate. Let me just make sure. Yep, sulfate. Sometimes I get them mixed up. Which is a -2. You need 1 sulfate and 2 hydrogen. So +2, -2, we're even. Or else, you could figure out the charges and balance it out that way. So hopefully that makes sense. I know that's a lot to take in, but make sure you finish your questions and turn them into me.